exponents. And in this lesson, we're going to learn the non-positive exponents. And here, when we say non-positive exponent, it doesn't mean that the base number is negative. So you have negative a, if you have negative a to the power of n to the nth power, it's still the positive exponent, right? Here, we're going to see what happens if I have a power which is minus n, which is a negative number. So first of all, we actually start from the special case where not just look at the negative exponents, but let's see the special case of 0. What happens if 0 as an exponent? For example, 2 to the power of 0. What is 2 to the power of 0? Recall that we have the definition of powers that is equal to n of the number itself multiplied together. But what happens if this then is 0? I cannot just say that there's 0 numbers multiplied together, then this can be any number, right? But then there's 0 terms over here, then what happened? So here we actually cannot go this way. We cannot go from the definition in the beginning. Here we need to first form a quotient of power. So 0 can be written as any number subtract itself. So first of all, 2 with power of 0 can be written as 2 with the power of m, or any number m minus the same number m. Then remember what we learned from the quotient of power. This equals to 2 to the power m divided by 2 with the power of m. And these two numbers apparently the same. So the quotient is 1, right? Basically the same number divided by itself. So this means 2 to the 0th power equals 1. Now, what happened from this example, you can see that it doesn't matter if the base is 2 or 3 or any number, this seems true, right? So now let's see, given any number a with the power of 0, can still be written as a to the power of same number m minus m itself, and then it can be written as the quotient or the division of a to the m's power divided by a to the m's power, and apparently these two are the same number, so the division is 1. So the conclusion is that any number a, if you have a power of 0, right, have a 0 as exponent, you always equals to 1. Doesn't matter the base number, base value of the number. So for example, let's see how can we utilize this conclusion to simplify the complicated form. So if I want to simplify this expression, first of all, I see a power of 0 over here, so then this, based on the conclusion or based on the definition of 0 exponents, this equals to 1 times x squared plus 6 times x squared, and it is just 7x squared. So you can either use the multiplication distribute over addition, or it's just simply the same term of x squared, 1 of it plus 6 of it, so that's 7x squared. So this is how we utilize the conclusion of power of 1 to simplify something. Okay, now after seeing the special case of 0, let's take a look at the negative exponents. Let's still start with some examples, like for example, let's use 3, base 3 for example. 3 cubed is 9 times 3, which is 27. 3 square is 3 times 3, which is 9. 3 to the first power is 3 itself, right? And now we even know that 3 with the power of 0 is 1. Now, what happens if this number keeps decreasing? Then the next integer number beyond 0 will be -1, right? And then the next will be -2. And I can still keep going to the negative power. So what are these values? So first of all, 3 to the -1 is 1 over 3 to the power of 1. So it's 1 over 3. And 3 to the -2 is 1 over 3 with the power of 2. So it's 1 over 9. Let's write one more term. 3 to the power of -3 is 1 over 3 cubed, and it is 1 over 27. Now you probably see the pattern. The number of power give you the same number like 3 or 9 or 27, but the negative exponents seems flip over your results into a fraction. So here's the definition. Any number a to the power of any number n, negative n, is equivalent to 1 over a to the nth power. So this simply converts the negative exponent to the positive exponent. And we already learned a lot about a to the positive power of n in the previous class. So this really helps you to convert the negative exponents. And you know what to do after that. So for example, let's use some other number, for example. So I have just writing a random number, number 23 to negative power of 6. Then this can be written as 1 over 23 to the 6th power, right? You can still further calculate this value by your calculator, but in terms of the simplification, then this is the way that you can simplify a negative exponent. And I can further use this conclusion to calculate the negative exponent of a fraction. So if I have 1 over 2 to the power of -3, then again, like, doesn't matter what number it is, I'm just consider this as one whole number. Then I can first just apply the definition such that this is 1 over 2 to the 3rd power. And then I can expand the power first. This is 1 to the third power over 2 to the third power. So that is 1 over 8. Be very careful that to know which number is your denominator as a fraction. And then this, again, if you're familiar with fraction, this simply just equal to 8, because you can flip this over if you have two fractions, 1 over something. But if you want to know how to write the equivalent calculation, this first equals to the number multiplied by the number of 1. Number of 1 can be written as 8 over 8. So that this 8 will distribute to the numerator and denominator such that this 2 be cancelled out from the denominator, so it's 8 over 1, so it's 8. So anyway, so this shows you that even for a fraction, then the negative exponents, it's really just taking the same 1 over this number by the definition, and then you can still simplify this by knowing some properties of fractions. And lastly, the power of reciprocal. Or I should say the negative power of reciprocal. After seeing that example, it is 1 over a to the nth power, and then it is 1 over a to the n, and it is a to the nth power. Right, so basically the power of reciprocal, or the negative power of reciprocal, can be written as this. Okay, let's check some more examples to enhance what we just learned. So first example, how are number of 2 to the negative 3 and 2 negative 1 cube related? So first of all, let's check the first number. 2 to negative 3 is what we just learned from the non-positive exponent. This is 1 over 2 to the power of 3, so it's 1 over 8. Okay, how about the second number? 2 to negative 1 cube. So first of all, I'm calculating, always calculate the things within the brackets. So 2 to negative 1, again, based on the definition, it's 1 over 2 to the power of 1. So it's just 1 over 2 cube. And then 1 over 2 cube is 1 cube over 2 cube. So it's 1 over 2 cube, which is 1 over 8. So these two numbers are the same, are equivalent. They both equal to 1 over 8. Okay, how about these two numbers? 2 minus n and 2 minus 1 with n's power. So first of all, similarly, 2 minus n power. By the definition of non-positive exponent, it is 1 over 2n's power. And the second term, 2 minus 1 n, we calculate the value from within the bracket first, so it's 1 over 2 to the nth power. I'm going to skip one step, so it's directly equal to 1 over 2 to the nth power, and they are also the same to each other. So this means we can generalize this question or generalize the examples what we just saw, and to prove or to check whether these two terms are equivalent to each other. In fact, before using a detailed calculation, you probably recall from the conclusion that a to the power of m and then to the power of n equivalent to a m times n, right? This, remember, again, this is power over power, so it should be multiplying. So in this example, a to minus 1 n is actually, if you just consider minus 1 is one of the power, n is the other one, then minus 1 times n is really just minus n, right? So this can be also derived based by knowing the power over power. But let's go back to this question. Let's use the similar way we learned from the non-positive exponent to show the conclusion. So we start from a to minus n. So first of all, this is equal to 1 over a to the nth power. This is just the definition of, based on the definition of non-positive exponent, right? And then 1 over a to the power of n can be further written as 1 over a to the power of n, and this is the power of reciprocal, right? Power of reciprocal. And then finally, 1 over a, it's really just a with the power of minus 1 to n, right? This is again the definition of non-negative exponents, right? So this is how we can prove it with the general case. Okay, let's see one more example. What is the largest number among the following numbers? So I have 1 over 8 to negative 11. I have 4 16th power. I have minus 2 34th power. I have 16 to the 8th power. I have 2 to minus 4, and then 2 minus 8th power. Which one is the largest? So obviously, there are different numbers, but they have similarities. All the base numbers is a multiplication of 2, and further, it's actually a power of 2. Like for example, 8. I'm gonna write it over here. 8 is 2 cubed, right? 4 is 2 square. 16 can be first written as 4 times 4, and 4 is 2 square, so 2 square times 2 square is 2 to the 4th power, right? So basically, every number can be written as a form of the power of 2. So let's see the first. I will just write this in in a vertical manner. So first of all, this is 8, right? This is just based on the definition of non-positive exponent. And then I can actually simplify these two powers first. So it's 8 minus 1 multiply minus 11 becomes positive 1 times 11, which is 11. And then 8 is 2 to the third power, and over the 11th power, that is 2 to the 33rd power. Okay, the second one, number 4 is 2 squared, 16th power, power over power, that's 2, is 2 times 16, which is 2 to the power of 32. Okay, this one, minus 2 to a power of 34. Now, 34 is an even number. So this is minus 1, 34 times 2, 34. Because 34 is even, the negative sign becomes positive. So it's positive 1 times 2 with the power of 34. So it's just 2 with power of 34, right? This one, 16, is 4 squared, or 2 to the 4th power, and then power of 8. It's 2 to the power of 4 times 8, which is 2 to 32. Okay, last one, 2 with the power of minus 4 times, it's just another power over power, times minus 8. This is 2 minus negative negative becomes positive. 4 times 8 is 32. Okay, now end up with the same base. So if all the numbers are base 2, then if a is greater than b, then 2 to the power of a also greater than 2 to the power of b, if a and b are both positive powers. So, or intuitively, 2 to the power of 3 is greater than 2 to the power of 2, or 2 to the power of 34 is greater than 2 to the power of 33 or 32. So among all these numbers, the highest power is 34, which means this number is the largest number among all 5 numbers. Okay, let's check 2 more examples to complete this lesson. The next example, to simplify x fourths, y minus 2, x minus 1, y fifths. Okay, to simplify this expression. So first of all, I can open the brackets and then change the order of the items to group the numbers with the same base, because I have numbers with base x, numbers with base of y. X and y, if you have different base, you cannot further simplify the exponents. Remember that all the conclusions are based on you have the same base, and then you can group or simplify your. So this can be written as, by expanding the brackets, and simply written as the product of the 4 terms, and then I can group the term with the same base together. And now you have the same base, so you can add the power together. This becomes x to the power of 4 minus 1, and this is y to the power of minus 2 plus 5. And then it can be eventually simplified to x cubed times 1 cube. Okay, the last example. To express 2 to the 12th power as the power of 1 over 8. So basically by rewrite this number equal to 1 over 8 with a certain power. So can this be done? First of all, 8 can be converted to, so 8 is a power of 2. It's actually equal to 2 cubed. So 8 can be converted to a number with base 2. So they are connected. So let's see how can we do the conversion. So before we before we start from the 2 to the 12th power, let's convert this 1 over 8 a little bit to get this closer to base 2 first, so we know that what to convert. So first of all, 1 over 8 is, remember the definition of non-positive exponents. So 1 over 8 is first can be written as 8 to the power of minus 1, and then 8 is 2 cubed. So we plug in 2 cubed to replace 8 with 2 cubed minus 1. So then this is 2 to the power of minus 3. So we want to convert this number to there. So which means if I have a power over power n, that is equal to two to the 12 times n, and I want this equal to 2 to the power of negative 3, then my 12 times n must be negative 3, and if I just solving n from here, n is minus 3 over 12, which is minus 1 over 4. So which means 2, 12 minus 1 over 4 is 2 minus 3, which is 1 over 8. So oppositely, 2, 12 is 1 over 8, taking the power of minus 4. If you take the fourth power, minus 4's power on both sides to cancel out this minus 1 over 4. Right? Or I'm writing in other way might be easier for you. So let's take another approach. So what if I have this number 2 to the 12th power equal to 1 over 8 with a certain power x, right? This is 1 over 8, this is x, which is unknown, which is the unknown power. Then I have 2 to the power of 12 equals 2 to the power of negative 3x. So which means I want 12 equal to negative 3x, And I can solve x from here. X is 12 divided by minus 3, which is minus 4. So if x is minus 4, then 2 to the power of 12 will be equivalent to, actually from here, 3 minus 4, and then 2 to the minus 3 can be then converted back to 1 over 8. Right, so then this number 2 to the 12th power can be written as a power of 1 over 8, which is minus 4 power of 1 over 8. So that's the how to solve this one.